different structure of the network optimized to fulfill a completely different function.
Right, and so one of the properties of this particular network is that it is a small world. What this means is that every node is connected to every other node by a small number of steps. And that's very different from the bucket brigade, where the first person is very, very distant from the last person in that line. But there are other kinds of networks that we utilize as well. We utilize densely interconnected groups of people whenever we want to accomplish something that requires a large amount of trust, where people know what to expect from the other people in their group. And so, for example, in the military, we typically train people in small groups where everybody is tightly connected to everybody else. And so, you would think, well, if this is such a good way to encourage trust, then why don't we all live in these dense networks all the time? Well, there's another kind of network that we are able to create, which is that what we want to do is we want to mix these densely interconnected groups of people with other groups that are densely interconnected, with some ties between the groups and some ties between other groups. And so this is work from Brian Uzi, who has thought deliberately about different kinds of organization that you would use in businesses to encourage creativity. And so specifically, in the production of Broadway musicals, what he was able to do is look at musicals like Pajama Game, West Side Story, Gypsy, and Fiddler on the Roof, and look at the individuals who created those musicals, and then see what happened after they created those musicals. Where did those teams go? And how did they mix with the other teams in order to create new musicals later on? And what he found was that there's this interesting trade-off. That yes, interconnected groups of people like the military squads, there tends to be higher trust in those groups, but because they all know what everybody else knows, they aren't getting any information from the outside world. And so there's this sweet spot, there's this Goldilocks point in terms of these networks being able to encourage creativity in the production of things like musicals and in the production of things like academic research. And so these are purpose-driven networks where we have thought deliberately how are we going to structure these relationships to achieve a common goal. But what we have really been interested in addition to these purpose-driven networks, is natural social networks. So how is it that we come to choose the friends and relationships that we have in everyday life, and what does that mean in terms of how we influence other people?
Yeah, so we've been studying, James and I, for the last 7 years, a variety of networks, and our work initially began with something called the Framingham Heart Study Social Network, a network that we built using archival paper records that had not been used for research. We spent $1 million and 5 years of our lives and collected these documents from these archives and painstakingly reconstructed the social network. And what we were able to do was to situate about 5,000 people in a network of 12,000 individuals, and we were able to take repeated cuts of the network across time and watch the social relationships change across time, and also have information about the individuals within the network, so that we had all kinds of information about what their behaviors were, what their emotional state was, what their health was, and the like, and see how this changed in order to try to tease out what was happening in the network. Could we discern a set of spreading processes or not? Now this shows what is known as the largest connected subcomponent of the Framingham Heart Study Social Network. There are 2,200 people shown here. And we have a variety of conventions on this slide that we're going to stick with for the rest of the talk. Every dot, of course, is a person. Every line represents a relationship. Here, the red perimeter dots are women and the blue perimeter dots are men. You can't really see that too well. But we're going to make dot size proportional to people's BMI. So bigger people get bigger dots. And then if you're properly obese, if your BMI is above 30, we're also going to color you yellow. Okay? So, and then the tie color indicates two different kinds of relationships. I forgot which is which right now, but orange is social relationships like a friend or a spouse, and purple, let's say, is a potentially biological relationship like sibling or parent-child. And if you squint at this network, and this was to our knowledge the first such picture that had been generated, you can see clusters of obese and non-obese individuals within the network. So just rendering the image and looking at it, and of course the Cartesian space here is arbitrary, right? This is a topological structure, this network, and it's been collapsed in 2 degrees and flattened. But if you just look at this network, you can see a kind of clusters of obese and non-obese individuals within the network. And this, of course, begs a certain set of questions. We used a bunch of fancy mathematics, which we can talk about. Either you can interrupt us or we can talk at the end. We're kind of on a roll right now, so I'll keep going. We used a bunch of fancy mathematics to document that the existence of the clusters was more than would be expected due to chance. We also were able to use these kinds of permutation tests to document that the radius of these clusters was 3 degrees. So my obesity status was related to the obesity status of my friends' friends, and my friends' friends' friends, and then it stopped at 3 degrees of separation. Okay? So something about me was related to something about these other people who I don't even know, who are 3 degrees removed from me. But a bunch of questions are raised by such clustering, not just whether it exists and how big are the clusters, but also what causes the clustering. And one can imagine a variety of possibilities. The first, of course, is the false positive, that it's just random that it happened. We've excluded that by some of the statistics I just alluded to. Another possibility, of course, is homophily, or birds of a feather flock together. So if we find individuals within the network who are connected to each other, who share similar attributes, this is a well-known property of human social systems. Educated people hang out with educated people. Tall people hang out with tall people. Overweight people might hang out with overweight people. People who tend to exercise might hang out with other people who exercise. There's nothing special about that, although actually one can problematize that and begin to investigate or consider why. Why would human beings do this at a very deep level, which we are actually doing. But for now, this is a nuisance for us because we're not interested so much in understanding the property of homophily, like did I form my tie with James because I resembled him. Another possibility is contextual effects. So here the argument is that it's not that I form my tie with James because we share a similar body type, nor that my body type is influencing his body type, but rather that we both share an exposure to some third factor, like a McDonald's opens up nearby and makes me gain weight and makes him gain weight, and it's not my weight gain that's causing his weight gain. And actually, in the widower effect, even 150 years ago, when people were publishing on this, they recognized this as a problem because, for example, if I'm walking down the street with my wife and a bus hits and kills us, but me a few seconds after her, you wouldn't say that her death caused my death. It's this bus that killed us both, right? So it's the same kind of problem that, of course, obtains in this setting. And finally, and most interesting for present purposes, is this notion of influence, where my weight gain, let's say, might cause James's weight gain, which we call induction. But all of these things go by different names in different literatures. Now, this was one of the innovations we were able to make because we had longitudinal information in the network. We were able to try to look at sequential events in the network, which helps bolster our confidence that something causal is going on, that my weight gain is causing his weight gain. And this is a little video I'm going to show you, which was both the most exciting and most depressing moment of mine, I know his too, scientific career. Because we had literally spat blood to get this grant, to collect the data, to get the software to work, to make this video animation I'm about to show you to work. And we stood there looking at it, just desperate to see the following thing. Because in our mind's eye, when we had begun this project, our image was that this social network could be understood as a sort of hyperdimensional surface. And that what we would see is that we would see, like if you dropped a pebble on the pond and you disturbed the surface, that you'd see like patient zero of the obesity epidemic. Like I would gain weight, and it would make my friends gain weight, and their friends gain weight, and their friends' friends gain weight, and this wave of obesity would spread out on the network. And so our fantasy was that if we could actually get this thing to work, we would see this wave of obesity spreading in this network after accounting for the change in the network as it itself evolved across time. So the convention here is the same as before. Every dot's a person. Bigger dots are bigger people. If your BMI is above 30, we also are going to color you yellow. Red perimeter dots are women. Blue perimeter dots are men. Here we only show non-genetic ties. So the gray ties represent spousal relationships. Here's a woman married to this man in gray. And the purple ties represent friendship relationships, people who are friends with each other. So any two people connected here who have similar body size, it's not because they share genes. It's because they've actually formed a social relationship with each other. In a minute, we're going to start in 1971. We're going to take daily cuts through the network for 32 years, and you're going to see a sea of yellow emerge. The dots are going to get bigger and smaller as they gain and lose weight. The network is going to change topology. Ties are going to form and break. People are going to be born and die. Some dots will disappear. Some dots will appear. Actually, they don't appear in this image. And I want you to tell me whether or not you see this wave of obesity, this sort of epidemic spreading in the population. There's a woman right here who's going to gain a lot of weight in a moment, and then she's going to move to the center of the network. There she goes. And then at the end, you're going to see some clusters of obese and non-obese. A lot of complexity here, right, as this thing changes across time. And you'll see a cluster of obese and non-obese, for instance, individuals form right here, coalesce. And now we're up to 2002 and a half, and it stopped. Okay, so did you see this wave of obesity or not? We didn't see it. We were so depressed. I mean, we literally were. I was just like, I can't believe it's not there. You know, it's got to be there. I can't believe it.